there are certain substances and the brain that will have certain effects on the heart. And those effects are called either a chronotropic effect or an inotropic effect. And so when we're talking about a chronotropic effect, we're talking about heart rate. And so there could be a positive effect of heart rate or a negative effect. Okay? Let's peek at that positive effect. A positive chronotropic effect will then do what to heart rate? Increase it. And if you increase heart rate, because we know there's a directly proportional relationship with heart rate and cardiac output, then that would increase cardiac output. So let's do that again and say that if we have a positive chronotropic effect, then that will increase heart rate, thus increasing cardiac output. All right? Now, if you have a negative chronotropic effect, then we decrease heart rate. If you decrease heart rate, then you're going to decrease cardiac output. Okay? So that's what a chronotropic effect is, and it's related to heart rate. Okay? When we're talking about an inotropic effect, we're talking about the forceful contraction of the heart. There could be a more forceful contraction of the heart. Of what specifically when we talk about? Ventricles. So when you have, let's specifically talk about that left one again. That's the big one that's very important to get blood to the rest of the body. If we're talking about the left ventricle forcefully contracting a little bit more, then that would be what we call a positive inotropic effect. And if you contract more, okay, then that's actually going to increase stroke volume. Right? So what's effect? The inotropic effect is related to stroke volume, right? Chronotropic effect related to heart rate, but inotropic effect, as it relates to forceful contraction of the heart, that's related to stroke volume, okay? So if you have a positive inotropic effect, then what you're gonna do is increase stroke volume. And if you increase stroke volume, then you increase cardiac output. Again, stroke volume is also directly proportional, has a directly proportional relationship with cardiac output. So if you increase stroke volume, you increase cardiac output. All right? Now, if you actually have a negative inotropic effect, then that means it's not such a forceful contraction of the heart, and therefore you're not pushing a lot of blood out to the aorta from the left ventricle. That means you decrease stroke volume. All right? So with a negative inotropic effect, we decrease stroke volume, thus decreasing cardiac output. Okay, I want you to rehearse that right now. After you finish watching this particular video, keep rewinding it or keep practicing what I just did. All right, and then you'll really get it. You'll get it just like driving a stick shift. You'll get it eventually. You won't even be second nature. All right, so let's just rehearse that one more time, right? And we'll say that you have your different effects. We have a chronotropic effect or an inotropic effect on the heart. And if it's a positive chronotropic effect, then that will increase heart rate, thus increasing cardiac output. You have a positive inotropic effect, then that's going to increase stroke volume, thus increasing cardiac output. But if you have a negative chronotropic effect, then you decrease heart rate, thus decreasing cardiac output. You have a negative inotropic effect, then you decrease stroke volume, thus decreasing cardiac output. Right? And so let's just talk about a couple of substances that are involved with that. And epinephrine. If you've ever heard of it or heard of it on TV or in movies, right? That's what epinephrine's doing. It's actually creating a positive chronotropic effect and a positive inotropic effect. Right? So therefore, epinephrine will do what? Increase heart rate, thus increasing cardiac output, and increase the more forceful contraction, thus increasing your stroke volume and increasing cardiac output in that manner as well. So you really get a lot more increase in cardiac output as it relates to the use of epinephrine. Right? The opposite would be a drug like acetylcholine, okay, which has the opposite effect. Okay, it's going to be a negative chronotropic effect, thus decreasing heart rate, decreasing cardiac output, and that means, and then acetylcholine will have a negative inotropic effect, thus decreasing stroke volume. If you decrease stroke volume, you decrease what? Cardiac output. All right? So those are examples of drugs that are used to do or cause those effects. And your brain utilizes those same substances as well. You naturally make those as well, and your brain will use those as well, whether the brain wants to actually do give a positive chronotropic or positive inotropic effect, or negative chronotropic or negative inotropic.